All right. So the thing is quite simple. When we talk about any quantity, right, we want to have a full and complete meaning to that quantity. For example, if I tell you, go and get 5 kg of sugar. Now, when I tell you that, you exactly have an idea that how much 5 kg of sugar would be, what size of the cover that you require to carry that 5 kg of sugar. Will you be able to carry on your own, or do you require help? How much space it is going to occupy, and how you're going to bring it, how heavy it is going to be. So you get a complete idea the moment I mentioned 5 kg sugar, right? Now, if you bifurcate all this, when I told you 5 kg sugar, what I meant was that 5 is a number, kg is a unit. So a quantity which requires only a number is called as magnitude, and unit is for 1. Unit is for 1 kg. You know that 5 kg means 5 times of 1, right? 5 times of this 1 kg. So when there is a quantity which gives you complete information only by providing these two details, magnitude and unit, any quantity which can be understood, which gives you a complete idea about that particular quantity only by providing two things. One is the amount, another is the unit. These type of quantities are called as scalar quantities. So scalar quantities would be those quantities which require only two things, magnitude and unit. For example, 5 kg, 3 seconds. You don't have to say up or down, right? Correct? All right. 3 liters of milk, and a number of examples could be there. But if I tell you that, can you get 5 kg sugar from a shop which is 3 kilometers away from your house? Now, probably 3 kilometers away, there could be a number of shops. Because if you think about it, this is your house and this is 3 kilometers, I can draw a full circle, right? And in this circle, all the shops which are coming on this circle would be 3 kilometers away, right? So then now I need to tell you specifically where, which direction, 3 kilometers in which direction. Are you getting it? Then you say, northeast, that go follow this road, you'll find a shop, correct? Which means that only by saying go to that shop 3 kilometers, so 3 was a magnitude, kilometer was a magnitude, it did not give you a complete information. You had to ask one extra question. What was that question? The question with regard to direction. Yes. So those kind of quantities, which in addition to magnitude and unit, requires one additional information to convey the entire information about that quantity. These type of quantities are called as a vector quantity. Got it? The idea of scalar and vector and their difference is clear. Okay. Yeah. Now, there is also a third quantity, which is called as a tensor quantity. Although you don't have that in the syllabus, so most of the tensor quantities we will treat it as scalar quantity only. That's why probably you might not even have heard of this name. But in reality, these quantities do exist. For example, now the term that I'm going to use, you would have certainly heard about it. Moment of inertia. Have you heard about this term?
Yeah, I is equal to some mr square.
Mr square.
Mr square.
Yes. Okay. So moment of inertia is defined for a particular axis. For different axes, moment of inertia is different. For example, if I take this book, this is one type of rotation. This is another type of rotation. And this is another
square by 12, ml square by 3. We used to have different formulas used on it.
Yes. So if the quantity is same, why do we require different formula? Because in addition to magnitude, value, and direction, how it is rotating, you also required an axis or a plane. So it required 4 things: unit, magnitude, direction and axis. All right. So But since in our syllabus, tensor quantities are not there, we treated moment of inertia as a scalar quantity. All right. Same is the case of stress. Stress is also a tensor quantity. All right. But again, we treated it as
a scalar quantity.
A scalar, but it is also actually a tensor quantity. Now, if in NEET exam, I get a question, moment of inertia is option A, scalar, option B, vector, option C, tensor, option D, none of these. All right. My answer would be tensor. All right. But if in NEET, the question is like, moment of inertia is option A, scalar, option B, vector, option C, both of these, option D, none of these. My answer
Both
would
of
be
these.
scalar.
Both of these.
Scalar.
The tensor also includes a magnitude and a direction also, right?
Yes. Tensor, in addition to magnitude, direction, it also requires a plane or an axis. But if tensor is not in the picture, you will treat it as a scalar. You will not say it is a vector. Did you understand? Because vector has got only a sense of direction. Understood? So those quantities which are tensor quantities are also treated as scalar quantities. Got it?
Okay.
All right. These are not vector. Either they are tensor or they are scalar. Understood? Vector is very well defined. Vector is very well defined. So if something is a vector, it is a vector. It's not like this or that. Got it?
It has a definite boundary.
Yes. So what would be the definition? The definition is it should not have more, it should not have less, which means it should have a magnitude, it should have a unit, it should have a direction. Only three things. All the, not more. A tensor has one more. Are you getting it?
Yes.
Scalar has one less. Now vector goes with a very definite definition that vector should have magnitude, unit, and direction. So those quantities which require these three things minimum to convey a complete information, these quantities will be called as scalar quantities, number one. Sorry, vector quantities. All right. Because they have direction, no? Magnitude, unit, and direction. These will be called as vector quantities. And if something is tensor, and if in the option tensor is not mentioned, I'll go with scalar. Simple.
Yes.
Yes. So at this point of time, we have only two types of quantities: scalar quantity and vector quantity. Because let's put tensor also into scalars. All right. So for now, but you know the truth, of course, right? And that only works if in the option tensor is mentioned, which is highly unlikely. All right. Okay. So for us now, the quantities are only of two types: scalar quantities and vector quantities. No problem. All right. No. Now, as I told you, how a vector is different from a scalar is with its sense of direction. Correct? So whenever you try to replicate, whenever you try to emphasize any particular direction, what you do, you point your finger this way, that way, there, here, like that. You say, no? Go there, go there. So this finger is replicating and is going to pictorially represent a vector. So vector pictorially would be represented by an arrow. Now, of course, we know that a vector will have magnitude. So an arrow will have head and a tail. The distance between the head and the tail of the arrow will be the value of the magnitude, and the direction of the head will show you the direction. No problem. Now, normally we divide the entire thing as top to bottom in vertical and in horizontal, which means if I'm drawing a line like this, the top becomes north, the down becomes south. North India, South India. All right. This side is west, this side is east. All right. Westerners, those people from England. England is that side, right? They came to rule us. So we say, no, they're Westerners. And east, East India is that side. Correct? Yeah. All right. Sikkim, Manipur, all these things are northeastern states, we say, right? So that's typically how we divide. Now, if you make an angle bisector, if you make an angle bisector at 45 degree, this will be exactly what? Northeast, northwest, southeast, southwest.
Southwest.
Did you understand? All right.
Yes.
So now we are going to see how do we understand the sense of direction? How do we understand a vector? How do we replicate the questions which are given in form of vectors? All right. And now let's start with the idea of vector quantities, because velocity, acceleration, force, all these are what? Vector quantities.
Vector quantities.
Yes. So a clear understanding of the vector quantity will give us a clear understanding of the force, velocity, acceleration, and all these. Is that okay?
Yes.
So now let's begin. First thing is, the pictorial representation of a vector is by an arrow. All right. This is the head and this is the tail. The distance between head to tail is telling you about the magnitude. No problem. All right.
No.
And the name of the vector, you can put it as capital or small. Whatever you do, there should be a right arrow at the head, at the top of it. This is a vector quantity. No problem. A is a vector quantity.
No.
So this is how you represent. It could also be like this. This point is A, this point is B. It can also be like A, B vector. Like this also, it's okay. No problem.
No,
Got
sir.
it?
Yes, sir.
Basics. Just give me a moment. Stylus has stopped working. Yes. So if you see, if there is a vector like this, let's call this as A vector. There is another vector like this, equal in magnitude and equal in direction. These will be called as equal vectors. No problem.
No.
If there are two vectors equal but opposite in direction, they will be called as opposite vectors. A is equal to minus B vector. Understood? If
Yes,
there are
sir.
two vectors which are parallel to one another, magnitude could be different also. These are called as parallel vectors.
Parallel.
So A vector is parallel to B vector. No problem. If
No,
there are
sir.
two vectors, they are pointing in opposite direction to one another. Anti-parallel vector. All right.
Yes.
Again, in the same way, in the same straight line, collinear vectors and all that. Okay. But what is important is zero vector or null vector. Zero or null. Zero or null vector is just like zero, like a value zero, and it is represented like this, zero vector like this. All right. It's just like value equal to zero, and basically it has got any arbitrary direction. All right. Its direction is not defined. It can have any direction. Magnitude is zero. Understood?
Yes, sir.
In the same way, you have unit vector whose magnitude is 1 and it just shows you direction. Just shows you what?
Direction.
Direction. Just shows you direction. No problem?
Yes, sir. No problem.
Okay. Now, most important thing, if there is any vector A vector can be written as its magnitude. This is how you write the magnitude. And this is how you write the direction. This is the normal representation. All right, this is the mathematical representation of a vector. Pictorial representation is like this. All right. Okay.
Yes.
Fine. Now think about this. If you are at some point O and you need to reach some point H, how do you get from here to here? There could be infinite number of ways, no? Somebody starts from here, can reach like this. Somebody starts like this, goes, and somebody can directly reach. Somebody will go. Correct? There
Yes,
are infinite ways in which you can reach from one place to
reach the
another.
final position.
Yes, suppose you need to go from Chennai to Delhi. There are infinite ways in which you can reach from Chennai to Delhi because Earth is round, right? So you just start in any direction. One day you will definitely reach. Correct? Okay. But then if I have to tell somebody about the exact direction, how do I do that? First thing is, if I want to do that, I need to define my origin. That okay, this is where I start. Origin means starting, no? So this is where I start. Now for us, there will be three axes: x-axis, y-axis, and z-axis. This is called as three-dimensional Cartesian coordinate system. And I have already explained it to you that in physics, we deal with three space coordinate and one time coordinate. Correct?
Yes, sir.
Which means this point will have some coordinate of x, some coordinate of y, and some coordinate of z. Correct?
Yes, sir.
So if I want to reach from O to A, there are two ways. Either I make a straight road from O to H direct, a highway like this. I call this as, let us say, H vector, which has got magnitude of H and direction of H cap. I define H cap as a unit vector, which is along this road only. So what I do, I have made a straight road from O to H. Okay. And I'm telling, okay, just go on this straight road, just go up to H value and in the same direction. The name of this road is H cap. All right.
Yes, sir.
Okay. Yes, sir. Let's take, for example, this is like 5, and let's just forget about Z now. Let's just deal with two coordinates only first. Let's forget there is Z. Let's say this was a plane, and I have made a road like this, and let us say the value is 5 from here to, no problem. All right. Now, one more thing we know, that this X value, this X coordinate and Y coordinate also will be something. So let us say this is 3, 4. What is the meaning of 3? Meaning of 3 is that on the x-axis, it is 3 units.
Covers
And what is the
3
mean?
units.
Yes, it means it is 3. This is 4. No problem.
No, sir.
Which means one method is to go directly like this. And this method can be represented as a vector form. This is called as vector form H, where you have magnitude of H times H cap. No problem. Another way is go 3. So this is, can I write H is nothing but go 5 units in which road, on which road? H cap road, and you'll reach. But if you want to reach over here, there is another way. What is that way? That you start
Covering.
going X in X direction 3, go along X, along positive X, plus then once you have reached up to 3, then start what? 4 along positive Y. No problem. This is another way. So we name this. We name a unit vector along positive X as I cap, along negative X as minus I cap, positive Y as J cap, negative Y as minus J cap. So can I write this H vector is equal to 3 I cap plus 4 J cap?
Yes, sir. Now
this type of form is called as a coordinate form, because now you have written it in terms of what? Coordinates. Understood?
Yes, sir.
There could also be in Z also. So 3I cap plus 4J cap plus 5K cap or something like that. So along Z axis, along positive Z, we put it as K cap, and along negative Z, we put it as minus K cap. So the problem is that this point H could have been anywhere in space, right? And if I keep on writing like this, if I keep on constructing a highway straight away joining from my origin to that point, how many lines do I have to draw? Or how many directions do I have to mention like this? Infinite, yes. It's just like you want to go by train, but you want your train to come at your house, pick you up, and then leave you where you want to go. Exactly.
An
So
ideal.
if everybody yes, if everybody starts wanting a train like that, will it work?
No.
No. That is why what we have defined is that you can't go directly. There is one way that in which you can, by making a straight line like that and by defining a certain direction. But in that way, you'll have infinitely many directions. So any point on this plane will always have a x coordinate and y coordinate. So why don't you choose this path of going along x and going along y? No problem. Are you understanding this?
Yes,
Suppose
sir.
the point is over. If I want to come over here, I know, let us say this is 2, 3. So can I say that if you want to reach from here to here, go walk 2 across this and then 3 across this. Correct?
Yes, sir. Yes.
So 2 across I cap
And
and
3
minus
across minus 3 cap.
minus j. No problem.
No, sir.
All right. So then
Yes.
that gives you this vector, which means this h vector can also be written as x I cap plus yj. No problem.
No, sir.
Is that okay?
Yes.
This is called as what? Component form. This is
Component.
called as what?
Component form.
So how do you get from component form to this form? So the magnitude of h vector will be equal to root over of x component ka square plus y component ka square.
Okay.
All right.
Yes, sir.
And what about direction? H cap. H cap will be equal to h vector divided by magnitude of h vector. See, this is how you have defined it.
Oh,
so
yeah,
what will
yeah.
be? All right. So what
Yes,
will be
sir.
h cap? H cap will be this vector, which is 3i plus 4j divided by root over of 3 ka square plus 4 ka square,
plus 4. Okay, sir.
which is 5.
If I have the direction also, I should follow the same method, like adding square plus y square plus z square if there is a third
Yes.
direction.
Yes.
Okay.
If there is a third vector,
direction.
that's how. So this is called as unit vector along the direction of h. Whenever they tell you that draw a unit vector along this or along that, you always do it like this. Is this point clear?
Yes.
All right.
Yes.
Okay. Then there is a question. The question says the position of a particle in a rectangular coordinate system is 3, 2, 5. Write its position vector.
Position.
Which means origin will be 0, 0, 0. The point is where? At some coordinate 3, 2, 5. So what will be position vectors? Position vector, let's call it as P vector.
P vector is equal to
will be 3i
cap plus 2j cap plus 5k cap divided by root over 3 square plus 2 square plus 5 square.
No. This is vector in coordinate form. If they ask you what is the magnitude of this P vector, this will be root over of 3 square plus 2 square plus 5 square. If they ask you magnitude, vector, this is the complete vector form. This is one way of writing vector. Did you understand?
Yes, sir.
See, one way is like this, drawing the vector. Another way is writing it in coordinate form in terms of xi cap, yj cap, and zk cap. Xi plus yj plus zk. Another form will be p vector is equal to magnitude of p vector times p cap. Correct? Now, once you have got this form, you can easily convert it into this form by writing the value of the magnitude as what? X square plus y square plus z square under root. You got this? How you will
Yes,
get
sir.
this? You already know the vector divided by this. Understood?
Yes, sir. Actually, saying the direct answer is, does the position vector mean that we should find the first in the format of x, y, and z, and actually divide it with the root over whole cap? That's the whole step, right?
No, 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 no. Position vector or any vector means that, so they are asking you to write the vector in coordinate form. No, coordinates are given.
Okay, okay. They aren't
If they
asking
ask
the
you to write
direction.
it in vector form, so there are two things. See, one is this form. This is called as coordinate form,
Coordinate
and this is called as vector form.
vectors.
So if they want you to write in coordinate form, this is the answer. If they want you to write it in vector form, then find this. All right, first write it in coordinate form, then find this, then write it in vector form. That is, p vector is equal to whatever this comes, correct? Whatever
Yes,
this
sir.
comes, p divided by, that is 3i plus 2j plus 5k divided by root over of 3 square plus 2 square plus 5 square. Correct? This will
Okay.
be what?
Yes.
This will be p cap.
The vector form.
This will be p cap, right?
Yes, sir.
This is equal to p cap. No problem. Now the
Yes, sir.
total vector will be magnitude of this times this. Again, when you multiply, you can see that the denominator cancels and you get this still back, the coordinate.
Yes, sir.
Understood this?
Yes, sir. So if they ask for the position vector, then representing it with the coordinate form is enough, as far as they are not
Yes.
asking for the direction.
Yes, and the thing is, how you would know? Of course, you will get the options right.
Options. Yes, sir.
So by just looking at the option, you'll come to know that what form they are asking or what form they are looking for.
Okay.
Okay?
Sir. Yes, sir.
Fine. All right. So almost it's like 2 minutes are left. So I'll just give you a break for now. Just comprehend everything that I have taught you. And then we come back again after 10 minutes and we continue our discussion on vectors.
Right.
So for now, you know two things. You know how to write the coordinate form and how to write the vector form and how to convert from one to another.
Yes, sir.
So now you know only from coordinate to vector. Now you don't know how to convert from vector to coordinate.
Vector to coordinate. Yes, sir.
All right. So only we know how to convert from coordinate to vector. All right. Just comprehend this and then we'll come to how we will be able to get the other way around. No problem. Which means if the road is built and then if I want to know that how much is this and how much is this, how do I find it? For now, though, I know this, I can build this road.
Yes,
all right.
Sir. Yes. Sir.
The next case, the road will be built and I want to know what is the x coordinate, what is the y coordinate, how do I do that? All right.
Yes, sir.
That will start after the break. I'll send you the link in 10 minutes. Okay.
Okay, sir.